Hello and welcome to Count Her Math. Today we're going to factor this polynomial. So whenever we start a factoring problem, the first thing I need to look for is a greatest common factor. Is there anything in common with every term in this problem? So something in common with 3x squared, negative 3x, and negative 36. In this problem, we do have a greatest common factor, and that is 3. All of these terms have a factor of 3 within them. So to factor the 3 out of this polynomial, I write the 3 here, add a parenthesis, then I'm going to go through and essentially divide each of these terms by 3 to factor out the 3. So 3x squared, if I divide by 3 or factor out the 3, that leaves me with x squared. If I'm factoring the 3 out of negative 3x, that leaves me with negative x. And if I factor 3 out of negative 36, that's going to leave me with negative 12. We've now made the problem quite a bit easier for us to handle. The next thing I want to check and see is, could I do grouping? With only 3 terms, I can't actually do grouping all that efficiently, but what I can do is split this center term into 2 separate terms. That way I can group our problem. So if I wanted to split negative 1x, I'm going to need to use c here. The negative 12 represents our c. Let me write this down. So I use my c, I'm going to use factors of c that sum b, and factors of negative 12 that sum negative 1. Our factors of negative 12 is 1, 12, 2, 6, 3, 4. And because it's negative 12, one of the numbers needs to be negative. So it's either negative 1 times 12 or 1 times negative 12. We need to figure out which term needs the negative in order to sum negative 1. 3 and 4 are one number apart, so that's where I'm going to look. And I need to have that 4 be negative in order for it to be negative 4 plus 3 is negative 1. So now what I can do is come back to my problem. And now that I know that it's 3 and negative 4, I'm going to split that center term to be positive 3x and negative 4x. And I haven't actually changed the problem here. I've just made it that way I can group the problem. And we don't want to forget this 3. He's going to follow us all the way through this problem. Now that I have 4 terms, I can look into grouping again. So I'm going to group the first 2 terms and the second 2 terms. Grouping x squared plus 3x, a common factor between those 2 terms, well, that would just be x. And if I factor x out of x squared, I'm left with x. And if I factor x out of 3x, I'm left with 3. Now the next set of terms, negative 4x minus 12. Our goal in this grouping is to make it so that both of these have the group of x plus 3 in them, so I can regroup after that. I'm in a little pickle where this one is x plus 3, but I have negatives over here. In order to fix this, I'm going to factor out a negative in order to switch the signs inside of this binomial. So I know I need to factor out a negative, but then let's also look what is the common factor. Well, 4 and 12 both have 4 in common. So if I factor negative 4 out of negative 4x, I'm left with an x. And if I factor negative 4 out of negative 12, factoring a negative out of that negative is going to leave me with positive 3. Now I have x plus 3 and x plus 3 in both of my terms here. So I'm going to do grouping again. And this time the greatest common factor is x plus 3. This first 3 just continues to follow us around. So if I'm factoring out x plus 3, I put that at the front. And then if I factor x plus 3 out of x plus 3, I'm left with x. If I factor x plus 3 out of negative 4 x plus 3, I am left with negative 4. So the factored version of this problem is 3 times x plus 3 times x minus 4. As you get more comfortable with factoring, you should hopefully see that pattern where the numbers that we found, the factors of negative 12 that sum negative 1, were negative 4 and 3. And our final answer is x plus 3, x minus 4. That's not a coincidence, and any time your a is 1, so in our case it was 1x squared minus 1x minus 12, anytime it's a 1 for a, this is going to be true. You're going to be able to say parenthesis x, x, and whatever those 2 numbers are is what will be the inside of your binomials. In our case, we do have that 3 on the outside that we just need to remember to add in. When A is not 1, there are other methods that we have to use, but for the nice pretty problems like this, we can use that pattern once we get comfortable with it. Like, share, and subscribe if you found this helpful.